broadcasting on the WebEx for those of you who are watching live. The rest of you are watching on a video on YouTube that I'm currently also recording on the other screen. So, um, how is that working for everybody? I walked around and saw a few people watching those. Are they clear? Is the audio bad? Yeah, I thought I have a feeling like when I'm over here, you can barely hear me. When I'm over here, it's like I'm like screaming in your ear. And so I could do like or like maybe one of the Madonna mics like the like hangs around. Yeah,
Look like a business mogul.
I would when
Success.
I it would encourage me to break out into spontaneous pep talks. Okay, so today's actually kind of I'm not gonna say simple, but we're not going to do too much. And this is one of those things where I'm just putting this part in this assignment so you can play around with another form of effects. So what I'm going to do is I'm going to put a little bit of steam coming off my coffee. For those of you who have asked about the secret of how I filled my coffee cup up, it's just a cylinder, right? So we're going to look at a couple of different things about how to get that cylinder to look like it's steaming, right? This also brings up a couple of things I wanted to chat with you all about, and this is actually this is something that like is a skill that you gain as you go along a little bit, right? There is because we can simulate stuff in physics, because we can make something so accurate, we can tumble around in this as if it's a real world. People sometimes forget that you're still just making a bunch of images for an audience, right? Like, it doesn't matter how you get that result. It just matters that that result looks good, right? So, for instance, in another class, somebody was asking me how do they simulate liquid pouring through a tube, right? They wanted to look like they were pouring liquid in a funnel and it was spiraling down this long tube and out the end. But you didn't see it going in and you didn't see it coming out. They just wanted that liquid to be spiraling in that tube. And I'm like, why do you have to simulate that? Why don't you just fake it? Because like as the audience, we're never going to notice a difference, right? If it's just a tube that's changing colors, why are you simulating billions of particles to make up fluid inside of this thing to get a couple of thousand pixels, right? So that's where this little cylinder in there comes in handy. That's because I know I'm not doing anything with that coffee cup, right? If somebody's going to pick up that coffee cup and throw it in somebody's face, that cylinder's not going to work, right? Coffee's hot, don't throw it in people's faces. Public service announcement. So we just have to figure out what level of turbulence we need in there. Like, I try to not shake my coffee too much. Usually it's relatively like still on the top. You may want to put like a little bit of a noise modifier or something on the bump to give it just a little bit of a wave or something like that. But so that's the first thing. The first thing is like, don't always worry about you having to be completely accurate with something, right? It just has to look right on the pixels on the screen, right? If something's happening off screen that nobody can see that's incorrect, I mean, is that necessarily important? Like you weigh the importance versus the amount of time you have to get it done, right? And sometimes all you have time to get done is the pixels you're going to see on your screen. Right? So that's the first thing. The second thing we're going to talk about a little bit more when we get into our final project, which is, and this is actually a discussion I'm having with multiple classes. I have started to notice like I get a lot of emails of questions that could have very easily been just Googled, right? And I don't want to say like I'm fine answering those questions, but that ends up with people will wait like 3 days to get an answer that was the first Google search, right? Like the first thing on the Google search. It's not so bad necessarily in this class. as it is in some other classes. I had somebody who waited outside of my office 3 hours to ask me a question, and my answer was like, let's type that question into Google. See what the first response is. That's your answer. Like, so I tell you that not because I mind giving you the answer, I mind helping you. It's that um, it's more to save you time, right? Like, there's a lot of things that you're like, why is that doing that? If you just type it in the same verbiage you would have asked me out loud into Google, a lot of times you'll find that thousands of other people have ran into that same problem, and somebody answered it in like the first few search results, right? Um, the reason I say that is because half of our job is solving problems, and you don't ever want any little challenge you come up against being sort of a roadblock for you, right? If you're like, why is my image showing up so bright when I use the IBL lighting, right? And you search that out, you search that, and like maybe somebody gives you something, and it's like, oh, I had that problem too. I clicked this button and it got better. That button is the button that says interpret that image as raw instead of RGB, right? And that's something that I know because I've made that mistake, and I had to Google that or ask people to find that answer too. But this is sort of a skill that we develop of being able to troubleshoot things, right? And I know that you have that in all of your other areas of life. Like if you're like, hey, how do I get to, a good Mexican restaurant? You don't just wait around until like your friend messages you back. Like you search it and you try to find it. So this is the same problem solving skills. Sometimes we have to implement. So I encourage you to do that because the last project you're going to run into all sorts of stuff that you've never done before, right? Every time we do that project, it's kind of I give you some creative leeway to run with it, and people run with it, which means they run into a whole bunch of other problems that you're each going to have your own bucket of problems that somebody else in the class maybe doesn't, right? So learning how to think through that just by using the tools that are available to you. Another really nice solution is F1. Anybody know what F1 does? Crashes the program.
I wouldn't be surprised.
Well, sometimes. Brings up the Maya help, right? Maya comes equipped with literally hundreds of free tutorials just inside of it, right? Actually, all programs, 90% of programs, F1 is the help menu, and a lot of times in 3D programs or 2D, any of the graphics programs, that includes a set of tutorials or questions, right? If you're like, I wonder what Bifrost is, well, just type in Bifrost in the search thing here, and it'll bring you up a bunch of tutorials. All right, so anyway, I wanted to hit that up because I don't want any questions you have being what we call them in the game industry showstoppers, right? Like where you're working, and suddenly you can't work anymore because you've hit a wall, right? Like there's like, oh, I don't know what to do next, right? That's going to happen, and part of your job is learning these tools on how to get past that, right?
Sounds like my life.
Huh?
My whole life could be summed up as a showstopper.
Yeah, show stuff. No, the show must go on. So we're going to spend a little bit of time today looking at fluids. Okay, this is a confusing terminology, right? So when we wanted to animate smoke or like particles in the air, we use particles, in particles, right? Cough was in cough. That feels relatively intuitive, right? When we want to animate flowing water, we use something called Bifrost, which sounds like snow, right? So,
Satan?
huh?
You mean Satan because Bifrost is evil?
Bifrost is evil. Bifrost isn't evil. Bifrost is complicated. Not necessarily even for the user, it's for the computer. You will literally have like terabytes of cache files sometimes. Like it's a ridiculous amount of calculation required to simulate fluid, right? So Bifrost is flowing liquid, right? What we use to simulate smoke or fire, and this is where this terminology gets a little confusing, is something called fluids, Maya fluids. Okay? And that's confusing. You're like, why isn't it called Maya smoke or Maya whatever, right? The thing to, yes?
That's because Bifrost was made with inspiration from two other main programs at the time, Homofrost and Heterofrost.
Again, backspace over all that. So the thing to think about of Maya fluids is it's about substances of different densities flowing, right? So it can somewhat be used as a liquid simulator, right? But it's really for things that when it says fluids, I think of it as fluid as in motion, right? Fluidity, right? Like the way that something flows, right? So it's things that sort of seem to propagate in a fluid nature, right? So fire works really well with it. Explosions, dust clouds, smoke, some liquid flow, right? But it's really hard to think of this as a fluid simulation, right? So let's just play around with it and see what we get out of that, right? I'm going to go over here to my effects tab, fluids, and I'm just going to create a 3D container. Okay, we're just going to look at what we get out of this. So when I create a 3D container, you're going to see in here that we get a couple of things. We get this fluid container. I'm just going to sort of move this out here in the middle so we can see it, right? Let's set this to 0. So we get a fluid container, and underneath that fluid container, we get a fluid emitter, right? That's parented underneath the container. It doesn't have to be, but they do that so where we can move this container wherever we want to, and the emitter goes with it, right? Now, if I hit play on this, so I'm going to right-click, playback speed, play every frame, max real time, right? So that means the fastest it'll play is 24 frames a second. So what we're getting is sort of this boxy container, right? This box, right? You'll notice that there's a little grid along the bottom of this box, right here. We'll talk about that here in just a second, right? And within that box, certain areas of space are changing color, right? Or changing color and density, right? So that's how I want you to think of this. This is not necessarily a bunch of particles. What we have is a, think in terms of like Minecraft, right? If you were to stack 10 by 10 by 10 boxes, right, you'd have a cube of boxes, right? That's really what's happening in here. Inside of this box is a whole bunch of invisible quadrants, right? And we're going to call those voxels, VOXELS, right? In fact, Minecraft is often referred to as a voxel game, right? You are sort of filling up volume, and that's really kind of where that term comes from. It's like volume pixels, right? Voxels. So what's happening is quadrants within this cube are changing properties, right? So this is a simulation of that happening, right? So imagine like if you had these boxes in real life, right? And one of them was filled with gasoline. Actually, let's say all of them were filled with gasoline, right? And I ignited one of those boxes, and that gasoline caught on fire. What would happen to the surrounding boxes of gasoline?
They'll pull out their phones and record the video.
No. Do it.
I was just asking if you asked.
So let's say we had a giant warehouse full of boxes, right? And like they're all stacked on top of each other, 10 by 10 by 10, right? And that box in the center, like they're all filled with gasoline. If we ignite that center box with a flame, right? It catches on fire. What happens to the boxes around it?
Everything else catches on fire.
But the one on the outside edge doesn't go next, right? It's the ones that are closest to it sort of ignite, and it kind of travels, right? That explosion would travel, right? So that's what's happening here. Is like each of those voxels have some simulation that's happening, and it's sort of like traveling throughout this system of voxels, right? So we have the ability to control a lot of that stuff over here in our attribute editor. So again, we have 10 by 10. We can imagine 10 vertical as well, right? And that's what we're getting, is we're getting all of those quadrants sort of filling up with steam, right? Or what appears to be steam. If we click off that, click on our fluid, right? You'll see we have the ability to change some of this information. Right now our base resolution is 10. If we set it up to something like 30 and go back to the beginning and simulate that again, you'll see that now I have more boxes, and you'll see that my simulation has more fidelity to it, right? More detail. This is like a 30 by 30 by 30 box, right? And we're able to see that simulation a little better. 40 will get even higher resolution. But because we're simulating so many things in there, the higher that resolution, the slower our simulation will go, right? So just right off the bat, this emitter in the center is emitting particles into this box, right? Now, if I move this emitter, I can move it pretty much anywhere I want to inside of this box, right? Simulate again. That emitter will start from there, right? But you see that it doesn't go outside of the box. In fact, if I move this emitter outside of the box and simulate it, right? Seems like nothing's happening, right? So that's something to kind of recognize, is that this simulation has to happen within that box, right? Which seems very limiting, right? Like if I wanted a building to explode and to simulate that, right? Do I just have to have all these giant boxes that are set to 1,000 by 1,000? Like, no. The answer is we can change some of that. Right? One of the things we can do is scroll down here. I'm going to start closing some of these tabs just so it's a little clearer where I'm at. I'm going to choose the fluid tab though, not the emitter tab. And so if I scroll down here, you'll see this auto resize. Right? And if I check that, I can click this auto resize button. It looks like nothing happens until I hit play. And then you'll see that this box will grow and change dynamically to sort of accommodate my fluids, right? Do I?
It's just never gonna stop.
Yeah. Yeah, it's good to just like grow forever, right? Okay. This is neat. Kind of looks like a little bit of like steam or smoke or something, right? I want to show you under content details. This is where this gets really powerful, right? So in Maya, we have the ability to pretty much, in particles, we pretty much have the ability to control like the object's weight and like friction and stuff like that. But really, it's always just a particle, right? It's either there or it's not there. In this, we have the ability to control a whole bunch of things. We have the ability to control density, like how thick is this substance within that voxel, right? We have the ability to control velocity, how much is it changing voxel per voxel, right? We have the ability to control turbulence, right? Is it propagating in sort of more of a straight line, or is there a lot of noise in how it goes? These last few are really interesting though. Temperature, fuel, and color, right? Mainly temperature and fuel. This means that we can create pretty much we can simulate pretty much an actual like chemical reaction, right? We can have an ignition fuel, such as gasoline, right? Well, if I light gasoline, it changes chemically into heat and smoke and fire and all of these different things, right? And I can do that in here. I can have a fuel that transfers into a color change and a density change and a turbulence change, right? And so I can use this to simulate like chemical reactions, kind of. Not like it's not like I'm going to mix some carbon with some oxygen or whatever. Like that's not. It's not necessarily that. It's just like the effect of a chemical reaction, right? So let's just start playing with a few of these. If I go to density, change my density scale, you'll see it either gets really thick or not thick at all, right? The thing that I would caution you on is not trusting what this looks like inside of the viewport. Because when I go to render this in Arnold, I should get a pretty nice render, but it's not necessarily going to look exactly the same. You'll see here it's looking kind of dark, right? Part of that's because I'm just using some area lights to light my scene right now. If I were to go in here and put a sky dome light in here, it's still looking a little gray, right? Yeah.
Hey, he didn't ask to be made. He didn't ask to be simulated.
So the thing I'm saying here is like, I'll see for a lot of people, they'll try to make it look perfect in here inside of the Maya viewport, and then they'll go render and they'll be like, why doesn't it look exactly like it does in the Maya viewport? And it's the same answer to why Maya Software's render doesn't look the same as Arnold, right? It's that it's using a whole bunch of different algorithms, a whole bunch of different physical calculations to calculate what that final thing should look like. So I start rendering, or at least doing the render samples of this relatively early. You probably want to wait until you have some form of lighting in place before you invest too much time into making this look perfect, right? So just to kind of, let me see, I can probably mount this in here, can I? Yeah, let's do that. So just so we can kind of see this change, let me get fluid. I can play around with the density here, and you'll see that it's doing something a little bit on that render, but you know, like that's not significantly changing what the density looks like in there, right?
Your screen isn't changing. Like your mouse is moving, but nothing's changing.
It's doing that thing again. Okay, let me pause and unpause the video. Stop sharing. Share screen. Okay, we back. Is that working now? Awesome. So if I hit play, there we go. We're going to see sort of what we're getting of it, right? So again, we can play around with our density in here, our buoyancy. We can play around with a whole bunch of stuff. This dissipation. This is kind of like how quickly it sort of disappears after it simulates. And so now you're seeing like it's getting a little bit more wispy on the edge because I'm playing around with dissipation, right? A lot of this is just sort of playing with it to get different results. Right? The reason we're not seeing a real-time change in here is because density does have a little bit to do with how it simulates. So there we go. So you're seeing like we're getting a little bit more like wispy spottiness by adding some noise, right? So I'm going to go ahead and hit stop on this like real-time render thing here. Minimize this. I want to play around a little bit with the turbulence of this and just sort of watch what we're getting over here in our simulation. Right? So currently we're getting this with the density. Actually, let me go ahead and turn my my buoyancy and my dissipation back down a little bit. All right. So this is something to notice. Buoyancy is changing like sort of like the weight of it. So if I turn that buoyancy way up, it's going to travel upwards and upwards kind of quickly. If I turn it way down, it's more like heavy smoke, right? It's like fog that's falling, right? or even steam that's falling out of a waterfall, right? So you can kind of play around with this. And we can usually go over or under -5, I think. I could take this to -10, and it's going to make it even heavier, right? Yeah. So I'm going to right now just go ahead and put that back up to like 2 or whatever it was before, so it sort of travels upward, right? And I'm going to go ahead and take my noise back down too. So just so you can see the effect of this turbulence. So turbulence is where we're going to start getting sort of those wispy curls and everything, right? So if I start turning up my turbulence, we're going to get stuff like this, right? It's going to be way more like steamy, spirally, all over the place, right? Okay. Let's go turn that down just a little bit more. The other thing we can do is turn up the frequency of that turbulence. If we're wanting to get some more like little wisps of stuff, right? Okay. But still, it's kind of rendering as this gray blob, right? Which isn't particularly helpful for us. So we can go down to not color necessarily, but shading. And you'll see a few things that we have some control over here. One is this object's transparency, right? So this is where this actually feels more like its density, right? The more transparent we get this, the more like thin and wispy this is going to appear to be, right? So even if you have fog, which we think of as kind of a white color, right? When that packs in kind of together, when it gets really dense, light still has a hard time getting through it, right? So what's really happening here is this color, even though this steam is white, right? When you get it dense enough, it's still looking a little dark, right? Now, right below here is this color tab. And so this is the color of this steam. Right? Go back, let's simulate a little bit more so we can get something that we can see a little bit better. Okay, so let's stop right about there, right? So this is the color of this this steam that we're looking at, right? Oh wait, before I go to that, we also have under this shading, this glow intensity. It doesn't really seem to do very much, so you can play around with that. I haven't gotten a lot out of that. One of the things we can do is if we want this to seem brighter and not so gray, is we can play around with the color. But if you see under selected color, like it's set to white, right? It's like, and the theory would be that there is no, like in physics, there is no brighter color than pure white, right? White is like the combination of all colors and like white light, right? But mathematically, like if we're just representing white as the number 1, right, and black as the number 0 or the non-number 0, then we can actually turn white up to 2. Right? It can be like, double white. I know that sounds weird, but really what we're doing is we're just adjusting a value here. So under 1, this value of 1, if I take that up to 2, you're going to see that it almost starts to glow, right? So think of it that. Like, it's not necessarily a glow feature. It's just we've gone past sort of the way physics would simulate white light, right? Okay. I'm not going to really, like, that's looking a little bit more like smoke in this room that we're rendering. But I'm going to go ahead and put that back down to 1 because I want to show you some other things. I can also change this to red, right? Or green or whatever color I want it to be. Right?
Actually, this will be pretty close already.
So we have green. The other thing is we can have more than one color in this fluid simulation, right? So I have this green as sort of the color of this this fluid, right? I can add an extra tab just by clicking out here on this little range, right? And so now I have 2 greens, and if I click on that second green, I can make it blue, right? Now, what we have is a gradient now from green to blue, but it looks like we're just seeing blue, right?
Yeah, you need to make it blue.
So the reason for this is because our color input is set to constant, which means it expects that we just want it to be one color throughout, right? But we can say, no, we want it to be 2 colors. And then Maya's question is like 2 colors based off of what? Like its height, its density, its temperature, like how does it distribute those colors throughout this object, right? So that's what color input is if I drop this down, I could make it based off of, let's say, Y gradient, right? Which means the bottom of it's going to be blue and the top of it's going to be green, right? Or I could even do it based off of X gradient, right? Which X is sort of, for us, it's like what's closest to us or furthest away from us. So the stuff that's closer to us is green, the stuff that's further away from us is blue. Or I could do it based off of density, right? The stuff in the center is blue, the stuff on the outside perimeter is green, right? This is how we can start getting some really interesting, like different looking simulations, right? If we're doing it based off of density, right? I could get really interesting here. I could make this centerpiece, I could make it bright red, right? Actually, maybe make it, yeah, let's go make it red, right? And then this section just right outside of that red, maybe I can make it almost orange, right? And then as we get out here toward the end, start going toward white. Right? And sort of shift these around about when we see what. Right. Oh, actually, I need these to be the other order. Let's try it that way. There we go. That's feeling much better. And so I can start making it feel like a small, heat explosion in the center that sort of ripples out, right? So we can do a whole bunch of different stuff with this. It takes a lot of finagling with these numbers to get a result that you might be happy with, right? Like this is what I get if I'm doing it based off of density. I could also do it based off of pressure, which doesn't really give us a whole lot of, there's not a lot of pressure in this whole thing. It's speed, right? It will change colors as it slows down. Right? Why is that cutting off there? That doesn't make sense. It has something to do with my, it has something to do with my background thing. So yeah, there's just a lot of different things that we can play around with in here to start seeing these different results, right? Doing something like this, we're starting to look a little bit more like an explosion out of this, right? Okay. So this is again, this is something that like when I talk about let's do this based off of density right now. So when I talk about like solving problems, everybody's going to have a different result for this, right? Everybody's going to have a different solution to get to that result. Maybe your breakfast scene is somebody came home late from the club and wanted to eat some cereal, right? And like you have it sort of a nighttime scene with garbage all over the table or whatever. One semester somebody made a post-apocalyptic breakfast. It was basically somebody eating a can of pinto beans with this giant survival knife and on a tree stump, right? And it was a really neat piece, right? There's not one lighting and steam situation for that, right? You kind of have to take that and say, how can I adjust all of these numbers to start getting the result I want? Just by trying to fit it into the scope of this class, I wanted to make it somewhat simple, right? You already get something that's kind of seeming like steam. or smoke. Let's just make it look like our coffee cup is steaming a little bit. It'll be very subtle. A lot of people won't even notice it. And that's kind of cool. Like effects is one of those concentrations or one of those focuses that if you do your job right, nobody thinks you did your job, right? Like nobody, like if you do your job right, nobody notices that background isn't real. If you do your job right, everybody thinks you really blew up something, not you simulated this inside of Maya, right? And so steam, like when we just see steam coming out of a coffee cup, like it's not like we're like, whoa, like it's like it just, we're used to seeing steam coming out of hot things, right? And if you do this well, it just kind of seems like some ambiance you're putting in the room, right? So that's why I picked that. Having said that, if you went if this is a witch's cauldron breakfast and it's got green steam coming out of it and little like tendrils of like, pink smoke coming out of it, whatever, play with this, right? If this is something you're enjoying, take it and run with it. I'm not going to dig into every little part of this just because that would take up a whole class. It actually already takes up a whole class. That class is called effects animation. So if you're liking this, that means that's where you're headed toward. You're headed toward doing more stuff in that effects animation class, right? I will show you one interesting thing, because right now it feels like that steam is coming from one little point, right? And that's not necessarily what our coffee cup looks like, right? We can have an object emit steam, right? Or emit all sorts of fluids, right? So I'm just going to go ahead and delete this fluid. And what I'm going to do is go over here and select this coffee object, right? This cylinder. I'm actually going to delete or duplicate this, Control D. And then I'll put the original one back down in there. And then I'm going to delete everything off of this except for this top cap, right? So I'm just going to go to my faces, select all of those. And so now all I have is this little disc, right? So under fluids, get this add component, right? And one of the options for that is emit from object, okay? So if I click that, it gives me an error, okay? How does it give me that? That should work. In fluids, add edit content, emit from object, right? So it's giving me that error, right? And the reason it's giving me that error is because fluids need two things. They need an emitter and they need a fluid container. We currently don't have a fluid container, right? We just have this object I'm trying to make emit, right? So we have to create a fluid container first. There's a couple of ways we could do this. One is we could just, and this is usually probably the easiest, is just go to 3D container, and it's going to create us one with an emitter in it. See it there? I'm just going to delete that emitter. Right? And then I'm going to move this fluid container in here to sort of surround that disk. So now that disk is inside of there. I think I just do that. I don't know if I have to select the emitter or not. Fluids. Add edit content, emit from object. And so now when I hit play, you'll see that whole disk emits steam, right? And that means I can move that disk back down into this coffee cup. I could even hide that disk if I wanted to. I could hit Control H, I could put it right there, hit Control H. It's still going to be the emitter, right? And so now it's going to look like my coffee cup is steaming.
I don't know what you did.
You mean do it again?
I got the box around the
Okay.
mug, but I don't know.
Okay. Yes.
I'd say going through your coffee. Is your coffee cup not set as like a glider?
Not yet, and we can do that. Well, yeah, I can show you that. But first, let me do that whole process one more time. I'm going to undo a few times. So yeah, once you get the box around it, I'm just going to select the object that I want to be the emitter. and it's like it has to be paired with a fluid container. So then I select the fluid container after that. So hold shift and select the fluid container. So I have both of those two things, and so now when I tell it to emit from this object, it knows which container to use to do that, right? So then I'm going to go to fluids, add edit contents, and it's emit from object. And so now we're going to get that thing steaming, right?
There's an error.
There's
It
an-
says that it won't do it, but something doesn't exist.
Okay. Give me 1 second, I'll help you because we're actually really close to being done. Because really all that's left now is playing around with the way this simulates to make it simulate like your Steam. The other thing is you probably want this to start simulating before frame 0 or frame 1, right? Just like we did with those other particles. We can control that on the emitter. I always have to go looking for this. I always forget where this is at. It's actually under, let's see, it's not velocity. I just did it. Under dynamic simulation on the fluid shape, and it's down here, it's at the start frame. So I can make that start frame negative 300 as well if I wanted to. I'd probably really just do for mine like negative 100. Right? And that means every time I go back to negative 100, that's where this simulation will start. Right? And that means by frame 1, right, my coffee's already steaming, right? Now from here, it's really just about getting this coffee to seem like it's steaming correctly, right? I can go in here with my fluids. I can, a lot of this is under this, I can click this auto resize, right? So that means it's going to automatically sort of build it the size I want it to be, right? Under content details, I can play around with density and make its buoyancy really heavy. That way it only travels upwards. Right. So now I have this like nuclear cup of coffee. And I can turn my dissipation way down, right? I want to turn that buoyancy down too. I'm going to turn that down to like 2 maybe. Right? We could turn down our velocity. Right now, its velocity is moving a little fast. I could do like 0.1. And actually, I can change all of this to where it doesn't send it in all directions either. Because if we look at this, there's 3 values here, X, Y, and Z. I could just set X and Z to 0. And I believe now when it comes out, it'll probably just try to go straight up more than anything, right? Now we are getting it coming through here a little bit. We can make this a make collide, right? So I can select this cup and make it collide. I have to select the fluid object first. Fluids, and then make collide. Right? And so now it'll kind of push it out the top. Right? And again, I'll probably go in here with this and make my container properties. I'll put that up to like 50. Let's see what that looks like. So now it's looking way different. Right? So we kind of have to play around with this until we get the result. And even after all of that, when I render, I'm still going to get a different result, right? I can barely see that, right? So I probably actually turned down my velocity too low. Let's set that to 1. Let's see what we get out of that. So I'm definitely getting some form of simulation out of here, right? We're gonna have to play around with this before we get sort of a final render we're probably happy with. Um, I'm also getting a lot of sampling noise in here, and I need to turn up my samples on my lights, but that's a different issue. Okay, we're like, again, this is really just play around with this. I want to see what results you get out of it, right? If you kind of get lost or get stuck, this video will exist on YouTube in a few hours. There's also another video from that playlist I shared earlier where I just walk through the entire thing of creating a reasonably decent steam for your coffee cup. But it's pretty much this same process, right? So, I know a few people have a few questions of stuff they've been working on there. Let's just take a second here. Everybody kind of pause what you're doing. Let's look up and think. That's the last I'm teaching on this project, right? In terms of like giving a lecture. The rest of the time between now and a week from today, right? And that's when this is due, right? The rest of that time is just time for you to be working on this, time for you to be trying things, right? So I wanted to give you a nice window of work time in there so you can experiment, so you can play with this, right? Next class period, I'm not going to be, let me double check, I think that was my plan. Next class period, I'm not going to be talking about anything in terms of Maya. I'll double check and make sure I'm correct on this. What I'd like to do is next class period, have the discussion about midpoint review, right? Let me make sure that's when I have that penciled in. So, wrong class. Yeah, that'll be a good time for it, right? So we will discuss that a little bit in class. And then you'll also have Friday to continue working on this, and then it'll be a week from today is when this is due. We're going to watch all of these in class. If we have time, if we can get through it, we'll do sort of a mini critique similar to what we did with the bottle and ball, right? I may, depending on how full the class is that day, we may do a slightly different technique that I actually really like too. Okay. So any questions about this? About when this is due? What is due? Okay. If so, refer back to the document I posted. But again, a week from today is when we're going to turn this in and look at it. After we're done with that, I'm going to, hopefully that day, assuming we have time, I'm going to kick off our final project, okay? And that's all we're really going to be working on, with maybe a few small like homework exercises, right? That's pretty much all we're going to be working on between now and the end of the semester, right? What we're going to talk about a little bit in the next class period, though, is sort of the reason I said run with this, right? These projects are what you're going to turn in the midpoint review class as part of your application to get into digital media, right? I want you to, so when you get that opportunity to have a little extra time, really what that is you getting the opportunity to make your piece look impressive, right? To make your piece a selling point for why you're a good candidate for the program, right? And that's a way to look at your work throughout the rest of your time here, right? Everything extra you can add to that is just selling you as an artist, right? It's making you look like a stronger artist. Eventually, that's what you're going to be trying to do to an employer, right? You're trying to convince them that you're the person who should get that job. So, yes.
Are you allowed to have like copyrighted stuff in your work?
Yeah. So the question was, are you allowed to have copyrighted work in your midpoint review stuff? We had people do stuff that's kind of like fan artish type stuff, like, and that's all right. Here's the thing to recognize about copyright. Copyright is it could be a whole. It usually is a whole classroom discussion. If you had Cher in the principles of visualization, I know she really understands copyright inside and out. I know she does a lot of talking on that. The thing to recognize about copyright is preventing someone from taking your work and making money off of it, right? There are a couple of situations that are considered fair use, like there are fair use clauses for stuff, that says even somebody's copyrighted work, you're allowed to use it to a limited amount, right? The point of copyright is to allow the creator to make money off of something for a limited amount of time, and then the results of that work is supposed to revert back to society, so society can benefit from it.
Right, the public domain.
Right, and that's what public domain is, right? And so the idea is that after the author has had enough time to make a reasonable amount of money off of that, it should go back to public domain. And public domain is something we all can benefit from. That's how we get Pride and Prejudice with zombies, right? Yes?
Didn't Disney lobby Congress to severely slow down the time it takes?
Yeah, Disney and several of them have really extended the amount of time somebody can hold a copyright for something. So that's a whole conversation, and it's a fun conversation because as artists we get to discuss. Oh, when should somebody get to take my art and make money off of it? And that's a very divisive question. But
Well, that's because that's what makes Disney all of its money is it finds old stuff with no copyright.
Yeah.
And it's like, well, we'll turn that to a cartoon.
but the question,
That was ours.
but the question was, were you allowed to use something that has copyright in it? One of the fair use clauses is using copyrighted material for educational purposes, right? So I can take a Disney clip and use that in my lecture to educate you, right? You can go to a museum and copy somebody's painting to learn how they became a master painter, right? And that's not copyright infringement. It's copyright infringement if you take that painting outside on the sidewalk and try to sell it. Does that make sense? So in this case, you get a little bit of some leeway on being able to use copyrighted material because you're using it to learn, right? And we remind you to be conscious of that, but each teacher has a different level of stringency on how much they will enforce not using anything copyrighted. I think that it's actually there's some benefit in having a little bit of I don't know. There was a lady who came through through this semester in Midpoint, who I don't know what the character is. It's an anime character. It's this little yellow egg-shaped character. It's freaking adorable, right? But she did a couple of fan pieces about that, and I mean that's cool. It was something she's excited about. Eventually, you want stuff in your portfolio that's not exclusively fan work. If the question you have is more about textures and stuff, that's a little bit of a different. That is stuff like textures.com. We can use those because those are provided for free. People are you can use these royalty free, right? When you just Google brick and you find a brick texture on Google, that's not been provided royalty free. And even though you're still covered by fair use, it's still kind of discouraged. Try not to do that because that's just not a habit you can do in the industry. There are several game studios that have gotten sued because people were hey, that background is my vacation photo. What did they And they realized that somebody just in that game studio just went and Googled palm trees and stole somebody's vacation photo and used that as part of a texture or something like that. So it's just a bad habit to get into. But is that kind of the areas you were talking about, or is it more the fan art side of stuff? Yeah, the one that this project is one that I kind of have a little bit of I'm a little bit lenient on because of the cereal box thing. I think it's really cool if you make your own cereal box, but in one version of this project, I had everybody make their own cereal boxes, and what I just got was a bunch of badly designed cereal box textures. It's yeah, I mean, you want it to look like Lucky Charms, I get it, and that's fine. There will be situations where you would use that in a real, if you're in Iron Man 7, if they're blowing up a grocery store, right? There's probably going to be some Lucky Charms boxes that go flying across the screen somewhere. So, huh? especially if they pay for it. We were watching, what were we watching? It's something on the Discovery Channel. It was like, I think it was that American Pickers show where the guys like go digging through people's barns or whatever. And like right in the middle of the show, they were like, let's stop and have us a delicious Subway sandwich. What do you say? And then they go in and they order a sandwich. And then they just sit there and eat their Subway sandwich. Like, back to going through people's barns. And then I was like,
That was shameless.
yeah, like completely shameless. Like, let's get a tattoo that says Subway. What do you say? Like,
Shameless plugs are amazing.
I love them.
You'll just have moments where you're filming stuff, and all of a sudden you're like, "Wow, I left that brisk bottle like in the background."
Yeah.
It's just like, I'm going to end your life with
Yeah.
PowerPoints.
I love when a Buick pulls up and like it just got like 10 seconds of like looking at the Buick logo on the cover before they get out of the car to go in for dinner or whatever. So, yeah.
My favorite thing is when an anime rips off McDonald's.
Have you saw that McDowell's or whatever it is from Coming to America? They actually opened one in New York. Yeah, like some guy just pretty much made like a McDowell's because it was like that was sort of the joke on the show. Anyway, I'm way off topic.
There's Whackaburger and Whack-A-Burger. The same thing, only they moved the A from Wacka to Whack-A.
Yeah,
But
this,
they're both real similar.
Really, they call McDonald's Macca's.
yeah. Okay, so I'm going to go ahead and stop the video because I just recorded like an extra 10 minutes of me talking about McDonald's or something. The rest of class today, though, is time for you to be working. I'll walk around, but again, it's your class time. If you're like, the way I work best is to go to PALS. Whatever. All that really matters is when we get in here on Monday, you have a finished project. Okay. So you use that time in whatever is most efficient for you. But I'll spend the rest of the time today helping. On Wednesday, we're going to talk a little bit about midpoint review. Whatever's left on time there is more work time. And then on Friday, that's just full work day for you. So, all right. Have at it. I'm gonna stop this video and then I'll bounce around.
The map will be